When it comes to legacy modernization, we're all at different stages of our journey. Some of us are still on premise, some of us have lift and shifted to the cloud, and some of us are taking full advantage of cloud native serverless architectures. It's really a spectrum of how cloud native we are, with all of us trying to get more cloud native to take fuller advantage of the underlying cloud provider. Now, legacy isn't something to be ashamed of, it's a system that worked, a fact of doing business, but those systems need to evolve to take full use of the cloud. Now, why do people evolve their systems? Well, first of all, there's security, but there's also agility, cost optimization, reliability, and availability. And although security is often a key point for this evolution, and surveys by IBM and others are really interesting in this space, it is that overall total cost of ownership that we're optimizing for, the reduced cost of building, but also running and supporting an application in production. Now, cloud migration was the original process of moving a company's business assets and processes to a cloud platform. But we're past that now. We're at cloud modernization, taking fuller use of the cloud through cloud native solutions to fully realize the optimal reduced total cost of ownership of building and running applications in production. When it comes to legacy modernization and cloud modernization in general, we're far past lift and shift. We're now making use of total cost of ownership as the key metric for cloud modernization. Now, typically, we would have used the 6R model when it came to cloud migration to map the migration strategy for a particular application. Retain, which is to revisit something later because it doesn't justify the cost to migrate right now. Retire, to get rid of something that's no longer business critical. To refactor an application, to rewrite and decouple that application to make further usage of cloud native services. To repurchase, which is to continue to use something off the shelf in place of something custom. And then the two more traditional cloud migration strategies of replatform and rehost, to lift and shift and largely not really change the structure of an application, to continue using largely the same core technologies, but have quite a simple migration strategy. Now, we're far past those lift and shift migrations when it comes to cloud modernization, and that's because we need to change the shape of an application to make use of full cloud native services. And this is why refactor style migrations are becoming key to cloud modernization. But this isn't without its risk. If we have an existing system with lots of features and functionalities, we can potentially be trapped by feature parity paralysis, waiting for the new system to have all the features of the old system before it can be migrated. This not only delays value to customers, but also can hide problems and increase risk. Instead, we need to take a more progressive strategy to continuously release minimum viable migrations and use that strategy to deliver value earlier, but also expose any problems earlier and decrease risk. When it comes to legacy modernization, we're trying to reduce total cost of ownership, that cost to build, but also to run and maintain our architectures. And to do that, we want to make use of more cloud native services. And serverless represents the most cloud native set of services that exist in cloud providers, the services that fully realize the reduced total cost of ownership of building and running applications. Now, cloud migrations have already happened. They were the lift and shifts to the cloud. But now we're looking at cloud modernization, how we can take fuller advantage of the cloud by making use of those more cloud native services and reduce total cost of ownership, ultimately targeting a fully serverless cloud native architecture. Now, modern serverless cloud native architectures are by their nature typically event driven, meaning they're systems that respond to events rather than an interconnection of different synchronous request responses. This is really useful because we build more loosely coupled systems, systems that are easy to change, but it also creates unique opportunities for progressive migrations. When we're moving from a system as is to a system to be, we don't want it to be one big bang migration release. This creates a massive paralysis of feature parity, meaning we have to wait for the different features and functionalities of the new system to exist delaying value to customers, but also increasing risks of that migration project. Instead, we can be inspired by minimum viable products, where we release a version of a product earlier to be used by customers to provide us feedback and mitigate risk. Minimum viable migrations are inspired by the same concept. It's a subsystem that can be migrated and be used by customers before the overall system is fully migrated. If we break down a migration from a system as is to a system to be into a series of minimum viable migrations, we can release regularly while also mitigating risk. Now, typically, an event-driven serverless architecture creates a unique opportunity for us to do this because we can emit events from the old system into the new system and vice versa, allowing us to progressively move different subcomponents of that architecture. The resulting architecture, being fully serverless and event-driven, is also much more amenable to change. If there are new technologies that come out later, it'll be far easier to swap out parts of that architecture, as it's already event-driven, than it is to do the current migration between a legacy, potentially monolithic code base to something more serverless and event-driven. So not only are we bringing benefits earlier, we're also creating systems that can be easily migrated in the future.